Hello and welcome to Engineers Mindset. So still on first principle differentiation, let's say we have y equals to 2x squared plus 3x, and we are asked to find the y over the x from first principle. So I said that a little increase in the value of y. So if I increase y by changing y, I will also increase x by change in x, okay? But recognize that this is x squared, so I'll simply have to square this term, okay, plus 3 into, I will also increase x by change in x, okay? So I'll have that y plus change in y is now equal to, this is 2. Of course, in the previous video, we expanded x plus change in x squared. So do well to look at the previous video. But this expansion is simply going to give us x squared plus 2x change in x plus change in x squared, alright, plus 3 into x plus change in x. So we have this. Alright, so let's now expand the brackets and see what we are going to have. We have y plus change in y is now equal to 2 times x squared will give me 2x squared plus 2 times 2x change in x will give me simply 4x change in x plus 2 times change in x squared will give me 2 change in x squared, alright, plus if I expand this bracket, I will simply have 3x, 3 times x is 3x, plus 3 times change in x is 3 change in x. So at this point, what I will do is simply send y over to this side of the equation. So we simply have change in y left here is now equal to, this is 2x squared plus 4x change in x plus 2 change in x squared plus 3x plus 3 change in x minus y. So I have that. Now recall that y is equal to, given as 2x squared plus 3x. Okay, so recall that y is simply 2x squared plus 3x. So which means in place of y here, I will simply replace it with 2x squared plus 3x. So this equation becomes change in y is now equal to, this is 2x squared plus 4x change in x plus 2 change in x squared plus 3x plus 3 change in x minus, now very careful at this point, minus, you open a bracket because the value of y is more than 1. So you have 2x squared plus 3x, so you have to be very careful. You open the bracket, you simply have minus 2x squared plus 3x. So you have this, okay? Alright, so let's continue over here. So we have a change in y is now equal to, this is 2x squared plus 4x change in x plus 2 change in x squared, okay, plus 3x, okay, plus 3 change in x, okay. Now take note, if I now expand this bracket to the minus, it becomes minus 2x squared, minus times plus also minus, so we have minus 2x squared minus 3x. So this is simply minus 2x squared minus 3x. Okay, so change in y is now equal to, so take note, this is now 2x squared minus 2x squared is off. I also have 3x minus 3x is off. So 2x squared cancels 2x squared. Okay, 3x subtract 3x. So we are now left with simply 4x change in x plus 2 change in x squared plus 3 change in x. Okay, so at this point, you divide all through by change in x. At this point, you divide all through by change in x. So I'll simply have change in y all over change in x is now equal to, I have 4x change in x all over change in x, okay, plus 2 change in x squared all over change in x, plus 3 change in x all over change in x. So I have this. So change in x cancels change in x. One of these cancels one of these. And then change in x cancels change in x. So I simply have that change in y over change in x is simply equal to, here I'm left with 4x. Okay, plus this is now 2 change in x. Okay, plus 3. Alright, so at this point, what I do is to take my limit. So the limit as change in x tends to 0, the function change in y over change in x actually tends to what is called the y dx. So I will simply have the y dx when I consider change in x to be what? 0. So that simply means that the y dx is now equal to 4x plus, this is 2 change in x, so I simply have 2. In place of change in x, I replace it with 0. Okay, 2 times 0 plus 3. Alright, of course, 2 times 0 is obviously out 0. So we are left with, that simply implies that the y, the x is actually 4x plus 3. That is the answer to that question. Alright guys, I hope you enjoyed this video. Please do well to like, comment, share, and of course subscribe to the channel. I will see you in the next video with more tedious questions on first principle differentiation. Thanks and cheers.